Hi students, let's continue with the implementation of lexical analyzer. So in this video I want to explain how to implement the lexical analyzer by using the Lex tool. So this is a tool which is used to implement the lexical analyzer. So this is an automated tool. So Lex is officially known as a lexical analyzer. So this officially we call it as a lexical analyzer. Its main job is what its main job? Its main job is to break up, let me write that point. Its main job is to break up an input stream. So whatever the input stream is there, that has to be break up into tokens. So just like a lexical analyzer. So it's just the lexical analyzer is officially known as a Lex tool. Okay, so its main job is to break up an input stream into tokens. So this Lex is an automated tool. We call it as a Lex is a tool for automatically generating a lexer, that is a scanner. So this Lex is a tool for automatically generating a lexer. So how it is going to be generated? How this Lex is going to support the lexical analyzer to convert the source to the target, means it's just convert the source program into series of tokens by using this Lex tool. Let's see. Let's take the Lex source code. Step 1. Let's take the Lex source program. The Lex source program is, let's take lex.l. Lex.l. L is a Lex source program. So this source program is sent to the Lex compiler. So with the help of the Lex compiler, it generate an output as lex.yy.c. So which is a input for the compiler. So the source program is converted into lex.yy.c, which is an input for the compiler. So in the step 2, this lex.yy.c, what is an output that output that we get from Lex compiler. So this acts as an input to the C compiler, and this C compiler is going to produce a.out. So a.out or a.exe, it's nothing but a lexical analyzer. Step 3. Input stream, whatever the lexical analyzer a.out we get, that will be sent to the sequence, produce a sequence of tokens. Okay, so far we have just seen this thing, input stream, lexical analyzer produces a sequence of token. So how internally, previously what we are seeing, input, lexical analyzer, and it generate a tokens. So input is a source code and the tokens. So here what the lexical analyzer is doing, the lexical analyzer is taking the character one by one and it is going to be converted into, it is going to check what are the identifiers and what are the tokens and what are the lexemes, everything it is finding, and it is producing a sequence of tokens to the as an output, that it is doing. But with the help of the Lex, okay, so here a Lex will be there. So with the help of the Lex tool, it's automatically generating the tokens. Okay, how it is going to generate? So it's with the help of the Lex C compiler, with the help of the Lex compiler, that Lex compiler is already compiled whatever the source program that is there, it's just taken the tokens and it is compiled, and it is with the help of the C compiler, it is producing exactly what the lexical analyzer wants. Okay, so don't be confused, just input and we need an output as a tokens. So in between this, there is so many operations of performing. Okay, so by skipping all those operations that are performed by the lexical analyzer, the Lex tool is automatically generating what exactly the lexical analyzer wants. So everything will be done in the Lex compiler. So what it is done in here, so it's a step 1, it's just take the source program lex.l and send to the Lex compiler, and it is generating one output. That output is again sending to the C compiler, and it is producing what exactly the lexical analyzer wants. So that will be stored here and sends the sequence of tokens. Okay, so this input stream, whatever the input stream that it is getting, so that source code and relating information to that source code will be sent to the lexical analyzer. Now let's see the structure of Lex program. Structure of Lex program. So don't be confused, the Lex tool is only, it is a source program which supports with the help of the input source code, it converted what exactly the lexical analyzer wants. Okay, so with the help of this tool, the lexical analyzer is going to generate tokens automatically. That is the main concept. With the help of the Lex tool, the lexical analyzer is going to generate tokens automatically. So what is the structure of Lex program? Declaration is the one section, and the next section is the translation rules, and the third section, total 3 sections will be there, auxiliary function. So this third section is an optional one. So total 3 sections will be there. Okay, so the declaration section, so what this declaration section consisting of? So it declares all the variables, declaration of variables. And translation rules, the translation rules have the form of patterns, actions, like that. So whatever the program that is, we are writing, taking the input stream. So that input stream will be represented in the form of Lex program. So that input stream, whatever we are taking, let us take A is equal to B plus C into D. So this input stream is going to be converted into with the help of the Lex program. So this is an input stream. Let me take, this is an input stream. So this input stream is written in the form of Lex program. So if we written in the form of Lex program, then the lexical analyzer can easily understand what are the tokens here and what is the operation it is going to be performed. So everything will be understand. So with the help of this input and with the help of the program, Lex program, the lexical analyzer is getting the tokens automatically. Okay, so the translation rules, what are the translation rules in the Lex program? The translation rules, this input stream will be represented in the form of just like a pattern, whatever the action that is performing. Okay, and what about the auxiliary functions? The auxiliary functions are nothing but the extra function, means these functions can be compiled separately. Can be compiled separately. So that's why I said this is an optional one, separately, and loaded with lexical analyzer. Okay, so this is the structure of Lex program. So let's take a small program, how this Lex program will be look like. Okay, So with the help of the input stream, whatever the input stream that we are taken, that input stream is represented in the form of a Lex program, so that the lexical analyzer can automatically convert into sequence of tokens. Let's see the Lex program. Lex program. So what's the program? The program was, let's take write a program to count the number of ovals and constants in a given grammar. So this Lex program I'll explain in the next video. Thank you.